Problem 1. Determine the single error correcting code for the message 11010. Assume the parity code is odd. So here the length of the data is 5. The parity used in this Hamming code will be a 4-bit parity. So the total length of the Hamming code will be 9. So the bit positions are 9. So let's now allot the position for the parity and for the data. So here the parity is allotted P1, P2, P4, and for 8th position parity is there. Then the rest is data, 3rd position, 5th, 6th, 7th, and 9th. Okay, now let us assign the datas. So from the message we'll take the data. D3 will be 1, then D5 is 1, D6 is 0, D7 is 1, and D9 is 0. So now we have to find the parity. P1, P2, P4 and P8 we have to find. So to find parity bit, okay, so first is P1. P1 is equal to, since the parity code we are using is odd one, we use XNOR operation. If it is even, we use XOR. Since it is odd, we are using XNOR. So we have to perform XNOR to some of the data bits. So let's select which data bits we have to. Let's choose which data bit we have to take. So for that, we can take it from the table. We can refer the table and we can do it. So here for P1 we have to take the first position, that is this one, this position. In this, among the data, this position is for P1, P2, D3, P4, D5, D6, D7, P8 and D9. So among the datas, only among the datas you have to do this. Among the datas are here. So only among the datas you have to see where is 1 in the, whether there is 1 in the first position. So in the first position in D3 there is 1, D5 1 is there, D7 1 is there, and D9 1 is there. So among the data bits you have to check. So here we will choose those data bits. So D3, D5, then D7, then D9. So that is equal to XNOR of, so D3 is, here this is D3. So D3 is 1, then D5 is also 1, D7 is 1, and D9 is 0. So for XNOR, what is the rule is, the output is 1 if there is even number of ones. So here the number of ones is odd, so the output is 0. Next, let's find P2, XNOR of, so let's choose the data bits. So in this we have to take the second position and see in which of the among the data bits in the second position 1 is present. So here 1 in D3, then D6, D7, okay, D3, D6 and D7. So that is equal to XNOR of D3 is 1, D6 is 0, so D6 is 0, then D7 is 1. So XNOR is when there is even number of ones, the output is 1. So output is 1. Next, P4 is XNOR of. So for this we have to among the data bits we have to check the third position wherever 1 is present. So here 1, no, this is the parity. Yeah, here D5, D6, D7, D5, D6 and D7. So that is equal to XNOR of 1, D6 is 0, D7 is 1. So that is equal to, so it's even number of ones, so output is 1. Then P8, so XNOR of, so for P8 only in we have to check the fourth position. So in only in among the datas only in D9 we have 1, so only D9. So that is equal to XNOR of D9 is 0. So if it is 0, the output is 1 in XNOR. So that is equal to 1. So the value of P1 is 0, P2 is 1, P4 is 1 and P8 is 1. So let's write the parity. So P0 is 0, then P2 is 1, P4 is 1, P8 is 1. So the final answer, the Hamming code is 0 1 1 1 1 0 1 1 0. So this is the answer. Problem 2. Detect the error in the given Hamming code. The parity code is odd. So this is the given Hamming code. So first let us write the parity and the data bits in this Hamming code. So this is the parity, second parity, this is the data, then parity, data, data, this is the parity and data. So here we have 4 parity bits, and here to detect the error in this code we have to find the check bits. So here since the parity bit is 4, we have to find 4 check bits. So next step is to find the check bits. So check bit 1, that is C1, is XOR of XNOR of P1, D3, D5, D7 and D9. So here we are using odd parity. So we are using the XNOR operation. So this is equal to, and this data bits we can choose as I explained in the previous problem. From the table you can choose. So XNOR of P1 is 0, D3 is 1, then D5 is 1, D7 is 0 and D9 is 0. So for XNOR, even number of ones will give the output 1. Next is C2. So this is equal to XNOR of, so P2 is 1, D3 is 1, D6 is 0 and D7 is 0. So even number of 1. So the output is of XNOR is 1. Then C4. C4 equal to XNOR of P4 is 1, D5 is 1, D6 is 0, D7 is 0, even number of 1, so output is 1. Next is C8. So that is equal to XNOR of P8 is 1, then D9 is 0. So this is odd number of 1. So the output of odd number of 1 with XNOR is, the output is 0. Next is the parity bit. C can be written as C8, C4, C2 and C1. So C is equal to, C8 is, the value of C8 is 0, and C4 is 1 and C2 is also 1 and C1 is 1. So the decimal equivalent of 111 is 7. So there is an error in bit 7. So we can find the error in bit 7. So the bit 7 is this bit. So you can now correct the code. So the corrected code is 011110. So since the error is this, so you 0 change to 1, then 1 0. So this is the correct Hamming code.